similar figure. Okay. So now we are going to discuss this chapter. It's very important chapter, okay, and very interesting also. You can see here. So first of all, we are going to discuss about some figures, okay. So you can see here we are going to discuss about the similar figures. What is the similar and figures? Okay. So you know that we have studied some kind of figures, especially the 2D figures like circle, triangle, okay, rectangle and square also, okay. So what is the similar figure we are going to discuss? Suppose that I have a circle, okay. Suppose I have a circle, I can draw a circle like this. What's going on? I want to check. So
I couldn't.
now you are you hearing me? I'm audible right now. I'm audible. Okay. Okay. See. Suppose that if we have a figure like triangle, okay, or circle, we can discuss. Like I have a triangle. One is triangle like A, B, and C. Okay, and the other triangle like I have a the different triangle like P, Q, and R. Okay, so you can see here the both triangles. You can see here the shape are different. Okay, you can see here the shape are different, but you can observe from here the size are different, but the shapes are uh, similar. Okay, can you observe from here?
Yeah.
Okay, so you can see there's the two triangles we have, and the most important thing that we have previously in the previous class, grade 9, we had discussed about the congruent of triangle. Remember,
Yes.
congruent of triangles. Can you recall what is the congruent of triangles? Properties of congruent triangles?
We determine how triangles are equal. Like my voice is echoing, but
Yes, your voice is okay, echoing and also jerking.
sorry, what?
Your voice is echoing,
Yeah.
not clear right now.
Okay. So congruency of we try to determine how triangles are similar by either looking at like the triangles.
Okay, okay, look at me. I just give you an example. See this. What is the congruent and similarity? Okay, the both are different, and what is the difference between the congruency and similarity? Can you see this? My hand. Okay, can you see this?
Yeah.
Okay, when I keep on, okay, you can see here when I put my hand, other hand, you can see here the both are covered to each other, right?
Yeah.
Can you see this? Okay, so both hands, okay, the perfectly covered to each other, right?
Yes.
Because of that the both hands have a same size and shape, right?
Yeah.
Do you understand? The both hands have same size and shape. Okay, can you see this? Okay,
Yes.
so that's why they cover each other perfectly, right?
Yes.
Okay, but this is the example of congruent. Okay, because the two hands are congruent to each other because they have the same size and shape. Do you understand?
Yes.
Okay, but suppose that if I take any child, okay, kid, and when I put here the hand, okay, you can see here the both hands, okay, are equal in similar in shape, okay, but not in size. Okay,
Yeah.
do you understand? Okay,
Yes.
the for example that suppose that Burj Khalifa, you can assume that if suppose to be that Burj Khalifa, and you can buy a model, okay, a Burj Khalifa from anywhere, any market. So you can see here the this shapes are same. Okay, the model of Burj Khalifa you can buy from anywhere. So the shape are same. Okay, but the size are different, right?
Yeah.
So we can say that the model or replica of a Burj Khalifa is similar to the Burj Khalifa, right?
Yes.
Okay, so when we are going to describe the congruent, that means we need two things. Okay, one is shape, okay, and
Yeah.
the other thing is size, right? Okay,
Yes.
but in the case of similarity, we are going to describe the similarity. So similarity of triangles or any other figure. So we are going to discuss only shape. Okay,
Yeah.
not size. Do you understand?
Okay. Yes.
Okay, so now in this chapter we are discuss about the triangles only. Okay, not other things. We are going to discuss for the triangles only, right? So you can see
Yeah.
here the example ABC, the triangle ABC and triangle PQR. Okay, so you can see here the both shape are the same. Okay, the both have the same uh, shape, triangle ABC and triangle PQR. Okay, so now we are going to discuss about the similarity and as well as congruency. So we need to discuss the two things. Okay, how can we describe the shape and size? Okay, so in the mathematics we have a two method, we have a two way to we can describe shape and size. One is angle and second is measurements of sides, right? Do
Yes.
you understand what I'm saying?
Yes.
Okay, so the shape, when we are going to discuss about the shape, so we need to discuss about the angles. Okay, so you can see here, suppose the angle A, angle B and angle C. Angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Okay,
Okay. Yes.
do you understand? When the
Yes.
two, when the angles are equal, okay, that we can easily can say that the two shapes are two figures are similar in shape. Okay,
Yeah.
similar to each other. Okay, but the different size, different measurement of sides, okay, we can observe from here that they are different in size. Okay, do you understand?
Oh. Yeah.
Okay, now when we are going to discuss the congruency of the two triangle 1, so we can use the symbol like triangle 1, triangle 2. Okay, congruent triangle 1 congruent to triangle 2. Do you understand?
Yes.
But in the case of similarity we are use this sign only, wave sign. Okay, wave sign, the
Okay.
triangle 1 similar to triangle 2. Do you understand?
Yes.
Okay, so now tell me one thing, that the odd circles are similar.
Yes, because circles are round,
Okay,
all,
okay,
but they're not all congruent. They're just similar.
yes, they just similar. And the same thing can we apply on the square also? Can we say about the square also? Same thing?
Yes, because like all squares have all sides equal
Hmm?
and all angles equal, but not all squares are equal to each other.
Hmm. In size. Okay. Okay, I hope you understand.
Yes.
Okay, so you can write down just introduction, okay, about and the difference of in between the similarity and congruency. Okay.
Okay. Okay. I'm done writing.
Okay, any doubt?
No.
Okay, come to the next. Check the next. Okay, uh, see the exercise 6.1. Fill in the blanks using the correct word. Okay, given in bracket. Okay, just simple. Okay, questions. Okay, we want to solve the simple question 6. Check this one. All circles are congruent or similar.
All circles are similar.
All circles are similar, right? Not congruent because they have a different radius. Okay. Now
Yes.
the next one, all squares are similar or congruent.
Similar.
Similar. Okay, very good. The next one is, so in this we can use similar and the similar. Now next is, all triangles are similar, isosceles triangles or equilateral.
All
All isosceles or
equilateral.
equilateral. Okay.
Equilateral.
What about the equilateral and similars? Do you know about the difference between?
Because in equilateral triangles, all angles are like equal to 60 degrees, but in isosceles triangles, we are not sure about the angles, like the two angles which are similar. We're not completely sure of their measurements, like if they're same in
Okay.
all.
Okay.
It's not.
So this all equilateral triangles are similar. Okay. Come to the next. The two polygons of a same number of sides are similar if their corresponding angles are uh, equal or proportional. Their corresponding sides are equal or proportional.
Okay, so the first one is equal, the second one is no, I don't understand.
See, two polygons of same number of sides, okay, are similar. Their corresponding angles are equal. Angles always equal because we know that the shape will be same. Okay, so the angles are equal and corresponding sides are proportional.
Okay.
Okay,
Yeah.
remember. Okay, because you know that the angles always describe the shape. Okay, and sides
Okay.
describe the measurement of figure. Okay, that means size. Do you understand?
Yes.
Now see this. The next, give two different examples of pair of similar figures. Can you give the example of similar figure?
Okay, we can say squares, all squares and all circles.
Okay, circle and square we can see. Okay, non similar figures. Can you give the example of non similar figures?
Different types of triangles.
Okay, and
Parallelograms.
parallelograms, quadrilaterals we can say also. Not parallelogram, we can say quadrilaterals. It will be better to describe. Okay, okay. I hope you understand. Now come to the next 3-1. State whether the following quadrilaterals are similar or not. Can you check this?
Okay. They're not similar because their angles are different.
Angles are different, right? Angles are different, so they are not similar. Okay, angles should be equal. Okay, when we are talking about the similarity, that means the angle, the two things we will discuss, okay, in this chapter. Okay, so keep it in mind only two things. Okay, one is angles always equal, angles should be equal. Okay, do you understand?
Yeah.
Especially when
Yes.
I talking about the angle, that means I am talking about the corresponding angles. Do you understand? When
Yes.
I talking about that angles, it means we have to keep it in mind that we are talking about the corresponding angles. When we are talking about the sides, it means we are talking about the corresponding sides. Okay, not only sides. Do you understand?
Yes. Okay.
Okay, so in the case of similarity, you have to remember the two things, always keep it in mind. One is that the angle should be equal. Okay, means the corresponding angle should be equal. And the next thing, that the the corresponding side will be in proportional. Okay, the
Okay.
corresponding sides are proportional. So you always remember this question number 4. Okay, it's very important.
Yeah.
Okay, always remember this statement. Okay, and believe me, this chapter is completely depends on the one sentence. Okay,
Okay.
the whole chapter number 6, completely depend on this one sentence. If you have to memorize, remember this sentence always. Okay, apply the sentence, okay, in every question, then the chapter will finish. Okay, I hope you understand.
Yes.
Confirm.
Yeah.
Very good. Now, do you want to write down?
No, it's okay. Understood enough.
Okay, come to the next. Now, see this. We have a very important theorem. Okay, actually, I can say this is the backbone of this chapter. Okay,
Yeah.
the very important theorem, and I can say the backbone of this chapter. Basic proportionality theorem. In a short way, we can say BPT. Okay, in a short way, we can say BPT. BPT, it means a basic proportionality theorem, or we can say Thales theorem. Okay, what is the theorem? Okay, the statement is very important also, so you have to memorize this statement also. If a line is drawn parallel to one side of a triangle, okay, to intersect the other two sides, okay, in distinct points, the other two sides are divided in the same ratio. Okay, now we are going to discuss, okay, one by one. First of all, we draw a suitable diagram. We need to draw a suitable diagram. Okay, key focus is very important from A, B and C. Okay,
Yeah.
and in this theorem, according to the theorem, if a line is drawn parallel to one side of triangle, so we have a side BC, I just draw a parallel side, okay, DE. Do you understand? This one
Okay.
is a parallel side. Okay, so I just write down here what is the given thing. Given, you can see here in triangle ABC, I have a triangle ABC. Okay, side
Yeah.
DE parallel to BC, side DE parallel to BC. Do you understand?
Yeah.
According to the theorem, we have to draw a side, okay, DE, which is parallel to the one of the side. Okay, I hope you understand.
Okay.
Okay,
Yes.
to intersect the two sides at a distinct point D and E. Okay,
Yeah.
now we need to prove what we need to prove. We need to prove. I just write down here to prove. We need to prove the thing is ratio of the sides. Okay, what is the ratio is AD over DB is equal to AE over EC. Okay,
Okay.
we need to prove this thing. Confirm? Do you understand?
Yeah.
Okay, now
Yes.
do you understand the statement of theorem? Tell me, do
Yes.
you understand the statement of, read again the statement of theorem and observe from the given and prove. We need to prove the thing and the diagram also.
Okay. So, if a line is drawn parallel to BC, then that line would divide the two sides. No, the two sides, they are divided in the same ratio if this line is parallel to BC.
Right, right, but we need to prove this thing. Okay, now in the process of, we need to some changes, so we need to some correction. We make some uh, correction construction. So the by construction, I just write down here by construction. By construction, I just draw a something that I have to draw BE. Okay, do you
Yeah.
understand?
Yes.
Okay, and DC. Okay,
Okay.
do you understand? I hope.
Yeah.
And one more thing that I have to draw a perpendicular like this. Okay, do you understand?
Yeah.
Okay, and I need to uh, BE and DC. And one more thing, I told you that we have to draw a perpendicular from D, okay, on AE, and the one more perpendicular from here. Okay, do you understand? I hope.
Yeah.
Okay, I can say like DE, and I just say P, this one, and this point is Q. Okay,
Okay.
so I just write down here one more thing, that DQ is perpendicular AE, right?
Yeah.
And EP is perpendicular AT. Okay,
Yeah.
now you have to write down till here first.
I'm done writing.
Okay, any doubt till here?
No doubt so far.
Okay, so do you understand the construction?
Yes.
Okay, because the construction is very important. Now we need to discuss about the proof. Okay,
Okay.
so check the one by one. First of all, I just take a one triangle ADE. Okay, in triangle ADE. Okay, and
Yeah.
one more thing, especially first of all, I want to describe the one more thing. It's very important. Then, do you know about the theorem we have discussed in the year, the previous year? Okay, grade 9. The theorem statement is the triangles are equal in area. Okay, the two triangles are in the same parallel line. Okay, are equal in a area. Do you understand? Do you know about the? Remember? Remember the
Could you repeat? I didn't
remember
quite
the theorem
understand.
statement of theorem. Do you remember the
Okay.
theorem? Triangles on the same base and between the same
Uh,
parallel are equal in area. I just write down the theorem. Okay, keep it in
okay.
mind.
Yes.
It's
Yes.
very
Yes.
important. I just write down here the theorem.
Hmm.
Okay, which is already discussed. Okay, I just write down here triangles are. I just write down here on the, what is this? Are on the same base and between the parallel are equal in area. Okay,
Yeah.
I hope you understand. Okay, now according to the theorem, you can see here we have a two triangle, the two parallel lines. Do you know that the two parallel lines DE and
Yes.
BC? Okay, and in the two parallel lines we have a two triangle BED and CDE. Okay, can you observe from
Okay.
here?
Yes.
Okay, the two triangles and the same base is BC. Can you observe from here?
Yes.
Okay, so the two triangles on the same base and between the parallel, okay, are equal in area. Now come to the discuss. First of all, I need to discuss, that means the triangle ADE. Okay,
Yeah.
and I want to find out the area. I just write down directly in a direct way, that area of triangle ADE. Okay, what is the triangle ADE? Can you observe from the diagram? Triangle ADE. Okay, can you find the area of triangle ADE? Students, can you find out the area of triangle ADE?
Right. Give me a sec.
Hmm? Hello, Sarah, are you hear me? Hello,
Yes.
hello,
Sorry. Something came up.
hello. I didn't get your voice. Hello.
Can you hear me?
Ah, yeah, now. Very,
Yeah.
very well. Okay. Now, now tell me about the area of ADE. Can you find the area of ADE?
AD, like
Okay, check
the
the
formula
triangle
is
ADE.
half.
First of all, you have to observe the triangle ADE. Can you observe from here? In the diagram,
Yeah.
triangle ADE. Okay, confirm?
Yes.
Confirm?
Yeah.
Okay. Now, tell me the area of ADE. What is the area of ADE?
Well, the formula is half into base into height, so that
Yeah.
would be
Yes. Now, we know that,
half.
I just write down here, the area of triangle is equal to B into H, right? Base into height,
Yeah.
right? So from here, you could observe the half base is AD and height is EP. Okay,
Height
1 by
is
2 into base is AD and height is EP. Equation number 1. Check the height. Height is EP, right?
um how? Oh yeah, okay, okay.
Obviously, the perpendicular is always considered as a height. Okay,
Yeah, okay.
understand?
Yes.
Any doubt?
No.
Very good. Now, come to the next. Check the triangle DBE. Can you observe the triangle DBE? Or I can say
Yes.
DEP. DEP is better. Okay, sound. I can say the area of triangle DEB. Now, area of triangle DEB, we can use the same thing again.
Yes.
Okay. Triangle DEB, same thing, 1 by 2 base into height. What is the base? Check the base. Base is
D
DE and height.
D
What is the height? Tell me about the height of triangle.
AP.
Base is DE and height is EP, the same height. Okay?
Wait, how is it EP? It's
Okay.
AP.
Huh?
It's AP, right? How is it
AP. How
AP?
AP? How AP? We are discussing about the triangle DEB. DEB. Check DEB. DEB. Mark my word. DEB.
B or P?
What I am saying that DEB. Triangle DEB. Do you understand the triangle DEB first?
Yeah.
Okay. Now the base is DE, right?
Yeah.
And what is the height?
Um. EB.
Huh?
E-
Height is EP. Remember the thing.
Okay.
Okay?
Yeah.
Confirm.
Yes.
Very good. Now, again, we are going to discuss. Now we are take a ratio of the equation 1 and 2. Okay? So the area of triangle ADE over area of triangle DEB is equal to half of AD into EP upon 1 by 2 DE into EP, right? So 1 by 2 cancel out, EP cancel out. From here I can write down AD over DE, equation number 3. Now, do you understand this equation also? Very important
Yes.
thing. Do you understand this thing also?
Yes.
Confirm?
Yeah.
Very good. Now come to the next step. Again, we are going to discuss about the triangle, area of triangle again ADE. What is the area of triangle ADE? Check.
Okay.
Now, this time we are discuss the area of triangle ADE again, but we need to change this. We need to change the base and height. So we are going to discuss this time the base is AE and height is DQ. So 1 by 2 base is AE and height is DQ. Equation number 4. Do you understand?
Okay. Yes.
Okay, this side. Do you understand?
Yes.
Very good. Now, this side we are going to discuss one more thing, the triangle DEC. DEC. Can you observe the triangle DEC?
Yes.
Okay. So write down here the area of triangle DEC is equal to 1 by 2 into 1 by 2 into the base is DE. Okay. Base is, what is the base is?
DE.
No. Base is EC, base is EC, okay, base is EC and height is DQ.
Okay.
Okay, do you
Okay.
understand?
Yeah.
Confirm.
Yes.
DE, actually I think we need to mistake here. This one is not a DE, this one is DB. Write down here DB. This one is DB, not DE. DB.
Okay.
Okay, confirm.
Yeah.
Now equation number, I can say equation number 5. Okay, check the
Yeah.
ratio again. Take the ratio of the triangles, area of triangle ADE, okay, over area of triangle DEC is equal to 1 by 2 into AE into DQ over 1 by 2 into EC into DQ. From here the 1 by 2 cancel out, DQ cancel out from here. So this one we can write down AE over EC. Okay, equation number 6. Do you understand this one also?
Yes.
Confirm?
Yeah.
Okay, sure? Are you sure?
Yes. Yes.
Very good,
Yes.
very good, very good. Now come to check the statement of theorem we wrote previously. Check the read the statement.
Okay.
Read the statement. You read?
Yeah.
Okay. Can you observe from the statement of this, the triangle are on the same base and between the same parallel, right? So we can write
Yes.
down here from equation 3 and 6. Okay, and
Yeah.
according to the theorem, okay, we have to write down here the areas of triangle ADE over equation number 3, the area of triangle. What is the area of triangle in the previous, which is DEB, okay, is equal to area of triangle ADE, because ADE the same triangle, ADE is the same triangle, then the area will be the same. Okay, do you
Yeah.
understand? The same triangle,
Yeah.
then the area will be same. Okay, for the triangle ADE. Now the triangle, next one, equation number 6, we have to write down the triangle DEC also. Okay, confirm.
Yes.
Now according to the 3 and 6, we have to write down what is the equation number 3. Equation 3 is triangle ADE over triangle DEB is equal to AD by DB, right?
Yeah.
So you have to write down here AD by DB is equal to an area of triangle ADE upon area of triangle DEC. From equation number 6, we have to write down AE upon EC, right?
Yes.
Okay, and check that this one, what we need to prove. What we need to prove? AD by
AD.
DB is equal to
AE by EC.
now see this again. What is this? AD by DB is equal to AE by EC. Do you understand?
Yeah.
Okay, so it's very important thing. I hope you understand.
Yes. I
Okay,
understood.
so I just write down here hence proved. Okay,
Okay.
now you have to write down, but be careful at every step. Okay, if you will write any wrong thing, that it will be negative impact on your study. Okay,
Okay.
now start from here. I have to write down, but be careful. If you
I wrote this one.
if you have any doubt, you can ask me in any step.
I wrote this one. Could you show the next slide from proof?
Confirm?
Yeah, I wrote this one.
Okay, now start from here.
Okay. I'm done writing this.
Done.
Yeah.
Okay, come to the next.
done writing.
Okay, any doubt?
No.
Confirm?
Yes.
Do you understand every steps? Because this one is very important. Okay, so you have to, first of all, you have to keep it in mind that this term is very important. The statement is very important. So first of all, you have to remember the statement and this proof also. Okay.
Okay.
So I just revise one more time. See this. We have a theorem is the statement is okay when we draw a line, okay, which is parallel to one of the side of a triangle, okay, intersect at two distinct point, then it divides the sides in a ratio. Okay, do you understand? In the same ratio that AD over DB is equal to AE over EC, right?
Yeah.
Okay, so we done some constructions, you can see here. So in this case you can see here, first of all we take the one triangle, okay, upper side, and the triangle this side. Okay, we can take the area of the triangle of upper side and the area of triangle this side, right? The next thing we have to take the area of upper side and this side. Okay, do you understand what I am saying that? Okay,
Yes.
just I just give you a trick to okay, memorize, and you have to learn easily. So first of all you have to take the area of upper side and you can take the area of this side, and again the same thing you can use the area of upper side and this side. Okay, so you have the area and you can take a ratio of the areas of both triangles. Do you understand? And the last at the last you have to apply the theorem. Okay, the theorem is we already discussed the triangles on the same base, okay, and between the same parallel, okay, are equal in ratio, right? Area.
Yes.
So
Okay.
now from here we can calculate. Now one more thing, sometimes that the examiner and ask about the change some the critical thinking. What is this? This one is we have to write down that AD over DB, okay, plus 1 this side, and AE over EC plus 1 this side. Okay, do you understand?
Yeah.
We can
I've
add,
seen this question.
okay, we add, okay, both side 1. Okay, now take LCM. Now you have to take LCM from this side, then it will be AD plus DB over DB is equal to, from here, AE plus EC upon EC, right?
Yeah.
Okay, so can you check this one? AD plus DB from the triangle, AD plus DB become AB, right?
Yeah.
Okay, and AE plus EC become AC.
AE is yeah.
Okay, so from here we can write down, it will be AB over DB is equal to AC over EC, right? Okay, this one is
Yes.
very important thing. This is the special case of, okay, hence proof. Okay, this one is one of the special case of BPT, right?
Yeah.
Do you understand this one also?
Yes.
Okay, now write down. Okay, this terms is very useful in the executions. Okay, from the exercise we will do. Okay, so keep it in mind.
Okay. Okay. I'm done writing.
Okay,
Hello.
Okay, done. Any doubt?
No.
Okay, very good. Now come to the next theorem, the converse of BPT. Okay, the converse of basic proportionality theorem, the same theorem. Okay, in short form we can say CBPT. In a short form we can say CBPT, converse of BPT also. Okay, converse of
Yeah.
basic proportionality theorem, right? Okay.
Yes.
Okay, so you have to observe this statement. Okay, I will be back within 1 minute. Okay.
Okay. Yeah.
Can you observe? Okay. Now you have to compare so both statements. Okay. The first is BPT and the second is converse of BPT. Okay. When you compare the two statements, the first statement says us that the if we have a parallel line, okay, to the one of this side, okay, is intersect at the two distinct point, okay, of two sides are divided in the same ratio, right?
Okay.
Okay, so in this theorem, but in the converse of BPT, the statement is if a line divides in two sides in a triangle in the same ratio, then the line is parallel to the third side. Okay.
Okay.
Okay, I just want to show the difference between BPT and converse of BPT. First of all, we have to discuss about the difference between BPT and converse of BPT. Okay.
Okay.
So,
Yeah.
what is the converse of BPT? In BPT, given that side DE parallel to BC, okay,
Okay.
and we need to prove, okay, keep in mind, it's very important, AD upon DB is equal to AE upon EC, okay.
Yeah.
But in the CBPT, the given thing is, the given term is AD upon DB is equal to AE upon EC, okay. And
Okay.
we need to prove, we need to prove, we need to prove that DE parallel to BC, okay.
Yeah. Okay.
Do you understand what I'm saying, that there is a
Yeah.
difference, okay? BPT, the
Yes.
giving thing, okay, and prove. Now converse of BPT, that okay, it will be converse, it will be inverse process, okay. Do you understand?
Yes.
In BPT which thing is given, now we need to prove in converse of BPT, okay. So we prove the thing in BPT, okay, which thing is given in the CBPT now, okay.
Do we follow the same method? Like, do we state that the proof,
No, no,
the theorem we stated?
we will use the different method of, okay, for the proof, but just we need to observe, okay. You need to observe the thing only.
Okay.
Do you understand? I hope.
Yes.
Okay, so you have to write down first this thing, okay. It will helps you to understand about the difference between the BPT and CBPT, converse of BPT.
Okay. Huh? Until when is the class?
Okay, done.
No, almost. Until when is the class?
uh, Only 1 hour, I think. We will take one more class, okay. Anything?
Do we need to go out somewhere? So, like, what exact time?
uh, More than 30 minutes.
Okay.
Okay, do you understand about the difference between the BPT and converse of BPT?
Yes.
We will continue this class, okay. We will complete this theorem also. If anything you want to change, then we will continue tomorrow. If you have anything issue, if you have any issue, we will continue, okay. tomorrow.
So we'll complete this theorem.
Yes, we will.
Okay.
If you have
Yeah.
any issue, that we will continue tomorrow. If you have, otherwise we will continue this now.
No, we can do this first.
Sure. Thank you. Now done, I think.
Yeah, done.
Any doubt?
No.
Okay. Now come to the statement of theorem that if a line divides into two sides of a triangle, so we have to draw a diagram first. Okay, we need to draw a suitable diagram. First of all, suppose we have a triangle A, B and C. Okay, and D and E we have a side. Okay, so what is the given thing we have to we have to write down here? What is the given thing? Given is in triangle ABC. Okay, the ratio is already given that AD upon DB is equal to AE upon AC, right?
Yes.
And we need to prove what we need to prove. To prove, we need to prove that DE parallel to BC. Okay,
Yeah.
confirm.
Yeah.
Now we are going to construction. Okay, what is the construction? Let we assume the E point. Okay, we have to assume that we have a E point is here, E dash. Okay,
How is it going? It's not
E
perpendicular, right?
E dash, E dash, not about the perpendicular, just a point. Okay, a point. Let a point E dash on AC. Okay, and we have to suppose that DE dash is parallel to BC. Okay, do you understand?
No.
Huh?
Like it's
What?
point, right? So where exactly is the point? I don't get. This
The
is
E
line,
dash
right?
point is near to E. Suppose that.
Okay.
Very close. Okay. I just supposed to be that the E dash a point, okay, is very nearby the E. Okay. Do you understand? I hope. And we have to assume or suppose that the DE dash is parallel to BC. Confirm? Okay. See, one more thing. DE is not a parallel to BC right now. Do you understand what I'm saying?
Yeah.
DE is not parallel side to BC right now.
So we're just assuming.
So we have to assume that DE dash, but DE dash parallel to BC. Do you understand what I'm saying?
Yes.
The two different things is going here. So first,
Yeah.
we need to prove this is not a parallel to BC. DE is not parallel to BC. We need to prove DE is parallel to BC. Do you understand what I'm saying?
Yes.
Sarah? Confirm?
Yeah.
Pretty sure?
Yeah.
Okay. Now, so we have another point E dash. Now we can say that DE dash is parallel to BC. Do you understand what I'm saying?
Okay. Yes.
Pretty sure?
Yeah. So we just prove that if E dash is parallel to DE dash is parallel to BC, then automatically we have to assume that DE is also parallel to BC?
No. DE dash is parallel to BC. We have to assume and it by the construction. Okay. Now come to the topic. We in a triangle AD upon DB. AD upon DB is equal to AE upon EC. Okay, equation number 1 by given. This is already given. Do you understand?
Yeah. Yes.
Now AD upon DB is equal to AE dash upon E dash C is equal to equal by statement of BPT. Remember the statement of BPT? What was the
Yes.
statement of BPT?
If the line is drawn parallel to BC, then AD upon DB, it's divided equally, and AE is equal to like AD, and DB is equal to EC.
Okay. So according to the theorem, we can write down that AD upon DB is equal to AE dash upon E dash C, right?
Yeah.
Okay. Now the equation number 1 and 2, you can see here the LHS portions are equal in both sides.
Yeah.
Okay. When the in equation number 1 and 2, LHS portions are equal, then the RHS portion will be equal also.
Yes.
Confirm?
Yeah.
So from here, I can write down from equation 1 and 2, when the LHS portions are equal, then the RHS portions also equal. AE upon EC is equal to AE dash upon EC T dash C, right?
Yes.
Equation number 3. Do you understand?
Yes.
Now, from here you can see that this one AE dash, okay, upon, I just write down,
Yeah.
take AE by EC plus 1, okay, add 1 both side, add 1 both side.
Yes.
Any doubt? We can add easily both sides, there is no issue. Okay.
Yeah.
Take LCM AE plus EC upon EC is
On
equal to
EC.
AE dash plus E dash C upon E dash C, right?
Dash C. Yeah.
Now AE plus EC become, check the diagram, AE plus EC become
AC.
AC. So I just write down here AC by EC, right?
Yeah.
AE dash plus E dash C become AE dash plus,
That is also AC.
that is also AC. Very good. Now this one is also AC by E dash C, right?
Hello?
Yeah. Okay.
Okay.
See this. So AC over E dash C. Okay. Do you understand this one?
Yes.
Okay. So AC cancel out from there. Then EC is equal to E dash C, right?
Yeah.
Okay. So from here we can say, I just write down this equation number is 4. So you can observe from here, from equation number 4, from equation 4, you can observe that EC is equal to E dash C, right? We got the EC is equal to E dash C, right?
Yeah.
That means the E and E dash both are the same point, okay? E and E dash both are same point, right?
Yeah.
Okay, so from we can observe here, so you can write down that E, you can see the diagram, we have DE is parallel to BC. We need to prove this theorem, hence proved.
Okay. So
Okay, easy?
this we're proving. This is the end of the question.
Yes. Understand?
Yeah.
Easy. Now you have to write down the two important theorem have completed. Okay, and tomorrow we will take some questions from the exercise and example also. First you have to write down.
Okay. Could you show the first one?
Yes, sure. From here, done this one?
Yes. No, there was that
Okay,
figure,
write down.
right?
Okay, write
Triangle.
down this one. Yeah.
No, I wrote this.
Okay, wrote. Okay, and check this one. Done.
Okay, this one, yes.
Okay, write down.
I'm done writing this.
Any doubt?
No.
Okay, come.
Okay, I'm done writing this.
Any doubt?
No.
Okay. So today we have completed the BPT and converse of BPT, right? Okay, and
Yes.
exercise 6.1 we have completed also, right?
Yeah.
And from here tomorrow we will discuss the examples and the next exercise, okay, based on BPT and converse of BPT. Okay, so you have to practice the BPT and converse of BPT, okay, without looking the solution. So you have to write down this statement first and prove by yourself. Okay.
Okay.
Try to prove. Okay, and the next rest of the portion we will continue from tomorrow. Okay.
Okay.
Now
So
tell me
we're done
anything
with
else.
after we're done with this chapter, can we do straight away Oswal? Because like I have summer vacation, right?
Okay.
And we're gonna do AP in class, which we already did over here. So I was thinking if we could have a bit more revision for this specific chapter before we move on to other chapters.
It's okay. There's no issue. Okay, it depends on you. Okay. From the next we first of all we have to complete this chapter, and after we will start. Okay, no issue. Okay.
Yes, okay.
Anything else?
No, nothing else. Thank you.
Okay. Okay, no issue. Okay. Thank you.